Okay, we're looking at question 68 from chapter 14. And it says, a block with a mass of big M rests on the frictionless surface and is connected to a horizontal spring of force constant K. The other end of the spring is attached to a wall. A second block with a mass M rests on top of the first block. The coefficient of static friction between the block is U. Find the maximum amplitude of oscillation such that the top block will not slip on the bottom block. So the max acceleration obtained is going to be equal to the angular frequency squared multiplied by the max amplitude. And so the max friction force is going to be equal to, force is equal to U times N, and the N is the normal force, which is equal to mass times gravity. And so if we use Newton's second law, we can use this equation here, f of x is, or summation of f of x is equal to the little f, which is the max friction force, and which is essentially the max acceleration is equal to u times g. So our angular frequency is equal to the square root of k over m, the big M, like the big block, plus the little block, little m. And the max acceleration is equal to angular frequency squared multiplied by the max amplitude, and the max amplitude is equal to the max acceleration over angular frequency. So if we sub in this equation here instead of using the angular frequency, so the square root of k over big M plus little m, we get the equation they're looking for, which is u times m, the little m plus big M multiplied by gravity divided by k. And that's going to be the equation there. Thanks.